Welcome to Mr. Benjamin's Math World. Today we are going to be working with factoring a trinomial by completing the square. So what we're going to do is we're going to factor this trinomial, which is in order. I mean to the second power, to the first power, and the independent term. It is already in order. That's the first step we need to have correct. Make sure that the trinomial is organized from the greatest exponent to the lowest, to the second power, to the first power, no variable. It is in order. Now we are going to factor it, and we are asked to factor by this method, which is called by completing the square. So what we are going to do is we are going to copy the first term, copy the second term, and we need to find a third term here that makes this trinomial complete. I said this trinomial, not that one. This potential trinomial. I have to make it perfect. So what I'm going to do, since I'm going to find another term here, I'm just going to bring down what I still have. The plus 10 equals 0. Let me put it further, and you will see why. Equals 0. Now, the question is, how do I get this third term? First, this term will always be positive. How do I get it? We take the second term, the B term, because this is A, B, and C term. A is the term square to the second power. B is the term to the first power, the coefficient, and the variable to the first power, and the number is called the independent term. So you take the second term, the B term, and when I say you take the second term, I mean just the coefficient, just the number, and don't even worry about the sign, and you'll see why. You take this second term, which is 7, you divide it by 2, and you square it. Always the second term divided by 2 to the second power. 7 divided by 2 to the second power, this will be 7 times 7 is 49, and 2 times 2 is 4. So 7 over 2 to the second will get us a fraction 49/4. So our third term will be 49/4. Right here. Let me erase this now. Now, I have already completed a trinomial, and this trinomial now is a perfect square trinomial. If you do not know about perfect square trinomials, you should. We've done that in previous videos, how to factor perfect square trinomials. So this is a perfect square trinomial, and we know that the conditions for a trinomial to be a perfect one are the following. The first term must have square root. It does have square root, which is x. The third term also must have square root. It does have square root, which is 49/4. And the second term is 2 times the square root of the first times the square root of the third. If you do the math, you will get the second term 7, for sure. So this is a perfect square trinomial. Now, what is the important thing to do here, and this is where many students make the mistake. If I added, when I got the third term, I had to add this number of fraction, in this case 49/4, in order to keep this side of the equation invariable, the same, not affected. I'm forcing the situation here. I'm adding 49/4, and in order to keep the balance of this side, since I added 49/4, I need to subtract 49/4, because this 49/4 and this minus 49/4 will cancel out, and it's 0. So I have done no harm to the trinomial, to the left side of the equal sign. I've kept it the same. I added a fraction and I subtracted the same fraction. how do we move forward? Simply by solving the perfect square trinomial. By factoring. We know how to factor it. The square root of the first term, since it's a perfect square trinomial. The second, the sign of the second term, always the sign of the second term, which is negative. And the square root of the third term. The square root of 49 over 4 is 7 over 2. Because 7 times 7 is 49 and 2 times 2 is 4. So the square root of 49/4 is 7 over 2. Once you close the parenthesis, to the second power. This trinomial has already been factored. Here is the factoring of this trinomial. Because it's a perfect square trinomial, and this is the way we factor it. What do I have to do now? I need to solve these fractions. It says 10 minus 49 over 4. I said fractions because we know that this 10 is also over 1. So I need to subtract these two fractions. And let's show the subtraction right here. 10 over 1 minus 49 over 4. And I know we do remember how to subtract fractions with different denominators. We find the least common multiple between the two denominators. In this case, it's a very simple one. The least common multiple between 1 and 4 is 4. And now we do 4 divided by 1 is 4. 4 times 10 is 40. Minus 4 divided by 4 is 1. 1 times 49 is 49. 40 minus 49 is negative 9 over 4. So the result of plus 10 minus 49/4 is the same as minus 9/4 equals 0. And now I keep on solving the equation by putting the like terms together. Yeah, the like terms, these two, I'm going to take the negative 9/4 from the left side of the equal sign. I'm going to move it to the other side. So when I move this term from one side to another, it has to be the opposite of the operation. Normally, we say the opposite of the sign, which is not always true. And I'll tell you later why not. So the operation here is subtraction, right? So I move it to the other side, and the opposite of the subtraction is the addition. And this is why I bring down x minus 7 over 2 to the second equals 0 plus 9 over 4. This would be x minus 7 over 2 to the second power equals 9 over 4. I need to solve this. Let me put this to closer. Exponent. It's right here. So I need to solve this. How do I get rid of the square? Well, the opposite of the power is a radical. So what I'm doing is I'm going to get the square root, because it's second power, this is a 2, even though it's not written. I get the square root of x minus 7 over 2 to the second equals the square root of 9/4. And now we change the power 2 for a radical. So the square root of x minus 7 over 2 to the second power equals the square root of 9 over 4. And now I may cancel the radical with the power 2. So I'm going to have x minus 7 over 2 equals to the square root of 9/4 is 3 over 2. Positive or negative? 3 over 2. Because 3 times 3 is 9 and 2 times 2 is 4. So it means that I'm going to have two solutions. The first one will be x equals negative 3 over 2 plus 7 over 2. And the second, this is the first solution, the second solution will be x equals to positive, or just without the positive sign, because you know it's positive, 3 over 2 plus 7 over 2. And then we solve each one. This is negative 3 over 2 plus 7 over 2. X1 equals 2. We subtract, since we have the same denominators, so I may say negative 3 plus 7, which is positive 4 over 2. So x equals to 2. First solution. And then the second solution is x equals to same denominators. This is 3 plus 7 is 10 over 2. So x equals to 5. These are the solutions for this equation. Now, something I need to remind you. If you take a look at this trinomial, you can see that it's a non-perfect trinomial because the third term does not have square root. And we know that we can also do it this way. It can also be done this way. We find two numbers. When we multiply the two numbers, we get the third term, which is 10, and we add them or subtract them, we get the second term. What two numbers multiply, you get 10, and we add them or subtract them, you get 7. The numbers are 5 and 2. I need to get a positive 10 when I multiply, so these two will be negative, because negative 5 times negative 2 is positive 10, and negative 5 minus 2 is negative 7. So this is a simpler way to solve it, but I was asked to factor by completing the square, so we completed the square this way. When you solve this, you will have x minus 5 equals to 0 and x minus 2 equals to 0. So x equals to 5 and x equals to 2. And we got the same results as when factoring by completing the square. And you say, but this method, it's a lot longer. Yes, it is. It is, because this is a non-perfect trinomial and it can be factored this way. But if you're asked to factor by completing the square, this is the way you factor by completing the square. So if this video was useful, if you like the video, feel free to subscribe and activate the bell in order to receive further notifications. See you next time.